And then we'll look at troubleshooting using the layered model. Okay, this is Mark rant mode on. Network documentation always seems to get short shrift. You solve a problem, something comes up, and it's the vice president of marketing has got to go into the conference room, and his laptop's not working right, and you hurry down there and fix the problem because they're breathing fire down your necks. And as soon as you finish solving that problem, oh, another C-suite guy comes in. He's got to have something fixed right now because he's got to go in the president's office. And you never get around to documenting the first problem. And then when that problem recurs again, because these C-suite guys are typically not technically competent, with respect, I'm going to say that instead of using a more accurate term, like they're idiots. And you don't remember what you did since you slept since then. So if when documentation, it's, you know, we network guys, we network technicians and engineers are always putting out fires and fixing problems, and they're keeping us so busy we don't have time to document this stuff. But documentation is really crucial because you can put it into your problem solution database, your incident software. And then when you see another problem that pops up, when I was at Harcourt, we found that about 75% of the problems that came into our tech support center, they were problems that had already been seen in the past and already been solved. So all you have to do is go look in your problem solution database and find the similar problem and see what the solution was for that, instead of having to do all your own research and, you know, kind of reinvent the wheel. So if you don't have time to do this, if you don't build up a solution database, you can't do this. And there's some free ones out there. You don't have to pay for it. So he's talking about documentation as such things as physical and logical network topology diagrams, network device documentation, and performance baseline documentation. Performance is a really important thing, because if you don't have any idea of what the normal baseline performance of, oh, how many packets per second is going through the routers and switches, how many disk sectors are being read and written by the disk channel of the server, how many CPU cycles and RAM memory, virtual memory operations are taking place in your server devices. If you don't have any idea what the normal performance is, how the heck are you supposed to be able to tell when something happens and something goes south, what was normal here? I never measured it during normal operations, so we'll talk about that. Okay, physical topology and logical topology. Physical topology is the topology of, you know, what's the number of that wire that goes from place to place. When we were in the classroom at South Campus, we had each of those four little RG45s, that 4-port patch panel that every student's desk had a little number, a serial number, like a 6 or 7 digit serial number written on the jacks, and the corresponding number at the other end of the wire that was back at the patch panel where the lab equipment was in the back of the room. It matched that number. So Tarrant County College has a way of tagging all their physical, what they call these guys call this the cable plant. All the wires that are in the ground and in the tunnels that connect all the buildings together, so we know where they're supposed to go. So the physical topology is more like a blueprint of a building. It shows you where the device is located and which wires connect from one point to the other. This physical topology graphic in this is not a great one. I would use more like a blueprint type of diagram for this. And we're not really concerned about things like IP addresses and routing protocols and things of that nature. In a logical topology, this is like we have on the top of all of our labs. It really doesn't matter physically. Is this router number 1 in the first rack or router number 3 in the last rack? You're just going to grab 3 routers and 3 switches and cable them together, and then configure each of these routers and switches for the S1, S2, S3, and the IP addresses and the interface ports are connected together properly, and you can bring them up and get some connectivity between them. So logical topology is just sort of in the mind of devices. I'll give you an example with Ethernet. Ethernet's got a physical and a logical layout. Physically, we're going to lay out all our wires that go from the Ethernet hub, the Ethernet switch, to all the devices. There's 20 ports on the Ethernet switch. And physically, the wires are going to go out in a star configuration or hub and spoke type configuration, kind of like radiating like the silk strands of a spider web. They're going to go out from the center where that hub is located and they're going to connect to all the end devices, all the endpoints in that particular room or building. However, Ethernet originally was not a star topology, but a bus topology. We literally had thick coaxial cable running in a line, like a bus line, from one point to the other, and we would, at various places, we would put a TAPA connector. We call them vampire taps under those wires and connect to a PC that was in that particular office. So this was the Ethernet shared topology. Everybody was sharing the same coaxial cable because the Ethernet designer stole this design from the Aloha project in Hawaii, where they use actual radio transmitters and receivers to use a shared data communication for some educational projects. So Ethernet is physically a star topology. It actually stars out. It used to be physically a real bus topology with a wire of thick coaxial cable as our bus cable that connected everything together. But the phone guys in the early 90s said, you guys are nuts, you should use twisted pair cables, it's much easier to maintain. We don't have to worry about when the computer's taken out for repair, chops the bus in half and the network connectivity is lost. So where is the logical topology of the bus, which Ethernet is a bus? It thinks it's a bus. So in an Ethernet hub or switch, in that printed circuit board is a long piece of copper tracing that recreates the Ethernet bus that connects all those devices together into this logical bus, just like it was in the old days when we used actual real Ethernet devices, old style Ethernet devices like hubs and coaxial cables. Okay, rant mode off. Okay, device documentation. We want to have records of what kind of hardware and software is being used in these devices. In a network device like a router or a switch, we would want to know what's the IP addresses of the ports on it, what iOS version that we're using in that software, keep up with the versions and when they need to be updated. In user devices like user PCs and network servers, we want to have an idea of what operating system it's using. Has it been kept up to date? What's the IP addresses? Is it running the DHCP service? Is it running the DNS service? So we have some idea what's going on in those particular devices. Okay, this is what I was ranting about earlier. We need to measure the operation of our network devices, and maybe sometimes the network guys are also in charge of the servers. In a bigger company, we tend to split these things out. In a really large company, we have network engineers and technicians for the routers and switches. We have virtualization servers for the guys that set up the racks of servers and spin up VMs. We have database guys that keep track of the databases. We have the storage guys that carve up storage from the network attached storage to storage attached network stuff. But in a small company, it might be one team that does everything. So if we're responsible for both the routers and the switches and some servers, we want to take some measurements at various times to get an idea of what's going on when things are normal, when things are going bad. So we're going to take a measurement using some show commands and maybe using simple network management protocol of our routers and switches, and do these on some various times. Do this for some normal business days. Do this for some days that are like the last business working day of the month. The network tends to get real busy because people are doing their end of month reconciliation reports and they're really loading down all the devices. Every morning at between 8 and 9, when people come and report for work and they all log into the systems, as a burst of activity as the Active Directory, Microsoft Active Directory domain services logs them in. Every afternoon about 4 o'clock in the afternoon, there's a big burst of activity when people say, well, I'm going home at 5, I better look like I did some work today, and they do more work. So a good idea is to measure at various times, measure on the last business day of the month to get an idea of the heavy traffic, measure it early in the morning and late in the evening when people are fixing to leave to see what your high traffic amounts are. Maybe measure for several days in a row and collect some data. Don't measure continuously, you'll collect too much data. So what type of data are we going to collect? Well, he talks about if you take too much data, it's hard to look at all this stuff. Let's look at things like interface utilization. So on a router or a switch port, interface port, you can use show commands, show interfaces, for example, and it'll give you some idea of what is the utilization of that port. How busy is it on a well, he doesn't measure it from 0 to 99% or 1 to 99%. Cisco devices measure it on a scale from 1 to 255, where 1 is not very busy, 255 is equivalent to like 99%, 100% utilization. So we want to get an idea how busy the interfaces are. If the interfaces are consistently way above 70%, you need to get more interfaces. You need to buy another router with more interfaces and split that traffic out. We want to look at the CPU utilization on that router or switch. Remember now that routers and switches are just like servers and desktop PCs. They have a CPU chip, they have RAM, ROM, they have memory, they have an operating system. And that CPU chip, if it's too busy, if you tried to use a branch office $1,000 Cisco router, you know, for a service provider BGP table, 750,000 entries, it wouldn't handle it. The CPU would crash because it's too much information for it to do. It's not that fast. You wouldn't use a $300 Dell desktop employee system to try to be the Microsoft Directory domain controller for your entire company. It wouldn't have the horsepower to do that, and the CPU would grind to a halt. So there's some commands we can type on the Cisco devices to see how busy the CPU is. You can type a command. He'll give you like in the last 5 minutes how much stuff has been going on. Okay, step 2. Let's identify some devices and ports of interest. So in this particular sample of this graphic, we're going to use the PC1, an administrator terminal. We're going to use a couple of servers, server 1, server 2. We're going to look at some router interface ports, and we're going to look at some key ports on the switches that go to the 2 servers or something of that nature. Okay, now how long should we do to get our baseline measurement of what's going on? So 7 days long, that's a good minimum. That's going to capture all your people coming in the morning and logging in and creating a burst of traffic, and all the people at 4 o'clock deciding they need to send those reports in to see, looks like they did some work today. So a week is a minimum, 6 weeks, no more than that. So he have average 2 to 4 week baseline to measure stuff. I would, if I make it a week or 2 to 4 weeks, I want to make sure that I try to capture that week that includes the last working business day of the month, so we can get our end of month reconciliation reports and financial report traffic to be a part of that traffic. So we got an idea of the real true highs and lows for the whole thing. So we're going to analyze our entire network and do it every now and then to see if we have capacity growth. We've added devices. We want to remeasure that to see what's going on. If you do not do this, and then something happens, and the server people call you and say, people are having trouble logging into our server, we think your network is bad, and you have no adequate measurement of what the network is supposed to look like, you have no defense against these guys. Believe me, dev guys, development guys, software guys, server guys always try to blame the network for something being wrong here, when in reality the problem is it's their poorly designed software. So if you've been using simple network management protocol or show commands, and you can show that the interface ports that are attached to those servers that these guys are administering, and they think that there's something wrong with your network where they feed it into your network, and you can show, I'm not dropping any packets. I don't have any interface resets. Every packet that's gone in and gone out is gone just fine, and we have plenty of capacity to spare. Then you've got something you could show them, and they can crawl back into their little development cave and look at their lines of code and try to figure out what's going wrong with there. They have bad code in their devices causing all this problem. 9 times out of 10, that's the problem. The network is unable to distinguish between these development guys trying to run their new software programs and regular traffic and say, I'm going to get mean and just shut the developers down. But you got to measure this stuff to be able to do this. Okay, here's some things we can type on, some show commands we can type on Cisco devices that we can use to collect different types of data, that we can use to try to compile this information as to what's normal operation in our enterprise. So I want to be able to, create my documentation on what version of the iOS is in a particular device. I can type show version. that will show us the iOS version. It shows us how long the device has run since it's last been booted up again. If it has started again for any reason, it'll tell you, well, was it started up because the power was taken away and reapplied? Did it start up because there was a software crash and he rebooted himself? Think about Windows servers, they boot themselves up all the time. We can show IP interface or show IPv6 interface, verify all the options that are set in that particular device, such as is the IP address, what's the IP address, what interface ports are being used. The one thing show IP interface brief doesn't show you is what's the subnet mask, what's the slash number. So I like the command show protocols, show prot for short, because it shows you that the interfaces are up and up or down. It shows you the IP address, and indeed it also shows you the slash number so you can verify that subnet mask is proper. Now for detailed information, that third command, the gray one, show interfaces. Generally when we type show interfaces, we're only interested in a couple lines at the top. I'm going to make sure that it's up and up, it has an IP address, it has a slash number, a subnet mask. Maybe if it's a serial port, I want to verify that it's, point-to-point protocol or frame relay protocol or Cisco native HDLC protocol. But there's a bunch of information down there that's even scrolls off the bottom of the screen, such as, how many frames per second, how many packets per second have been transmitted here? How many errors have there been? How many RUT Ethernet frames or collisions have occurred? That should be close to 0. If those numbers are climbing, you've got a hardware problem with the interface port, or probably far more likely a wiring and cabling error with a bad crimp on an RJ45 or a corroded connection or something of that nature. So show interfaces can show us a lot of information about that to try to zoom in. We'll talk about this more when we go into troubleshooting. The show IP route command shows us the routing table. If it's not in the routing table, he can't deliver it to it. So we want to make sure the routing table is consistent depending on which type of routing protocol we're using. Now he is showing EIGRP and BGP here as an example. Just remember at the CCNA level, we are only OSPF, Open Shortest Path First, is the only routing protocol that we're really responsible for knowing much about how to configure it. We're only supposed to know a little bit about EIGRP, that it's a distance vector routing protocol, and it has a certain administrative distance, but that's about all you know about it. Border Gateway Protocol, similarly, is a CCNP advanced routing topic. Show CDP neighbor detail. I like show CDP neighbors because when you're doing a lab, you can verify that the proper port on this device is connected to the proper port on the neighbor device. And if you type show CDP neighbor detail, it can show you a lot of extra information about that neighbor device is connected to it, like what is his IP address. Well, that's handy to know if I want to tell that into it. What version of the iOS is there? What are the capabilities of that? I've seen some questions in the real Cisco test where they show you show CDP neighbor, and then they ask that device that's connected to this router R1, that device, what kind of device is it? Because it'll show you, is it a switch? Is it a router? Has a capabilities column. The ARP table, show ARP, and the equivalent in the IP version 6 world is show IPv6 neighbors. I want to see what devices are connected and been heard on the basis of their 48-bit data link layer MAC address. Show running config will show you the whole guacamole, everything that's in there. Show VLAN will show us on a switch how many VLANs have been created. And then show port will show the status on the ports, status of ports on the switch. And then there's a command at the end. If you are in any type of anything bigger than 25, 50 people enterprise, you're probably going to want to contract with Cisco when you buy your Cisco devices. And always go to one value-added reseller or VAR to get all your stuff from, because you'll get the best deals if you give them all your business. So don't go to Amazon to buy your Cisco routers and switches. They're not an authorized Cisco reseller. If you go to a value-added reseller and choose one organization in your area, that's pretty good, and you'll be able to get the best deal from this one group. All your IBM PC laptops, all your routers and switches, get it from this one supplier to get the best deal. Cisco tech support option, Cisco SmartNet, that you always get a free SmartNet for, I think, 3 months or 1 year when you buy a Cisco device. But once that runs out, you will purchase it on a recurring annual basis. It is possible to buy Cisco devices with 3 years of SmartNet at a slight increase in cost. So when you have a problem with your Cisco device and you have maintenance with them, you call the SmartNet line and you report you have a problem, and you report, is this a severe problem? My business operations have stopped, or is it a less severe problem? And when they get in contact back with you, one of the things they're going to likely ask you to do is go to the device that you're reporting the problem with and type show tech support. And when you type show tech support, you're going to get pages and pages of stuff scroll across your screen. It won't stop and wait for you to press the space bar. But what you're going to do is similar to before when we saved our running configuration. We opened a log file to the interterm, which would copy and paste everything that appeared on the screen to a text file, like a notepad file. You're going to type show tech support, capture that to an ASCII data file, a text file, and you're going to email it as an attachment to the support engineers at Cisco SmartNet. And then they're going to be able to, instead of sitting them on the phone and asking you to type show this and show that, they're going to get everything. It's going to be like every possible show command in the world in one big gulp. It's sent to them, and then they can analyze it and call you back or text you back later and let you know what they found and recommend what the next step would be. So watch out for show tech support. Once you type it, you can't stop it, and it can go on for like 5 minutes with screens and screens and screens full of stuff. Okay, and now we're going to talk about the troubleshooting process. Okay, we're back to this three-stage troubleshooting process. It used to be 6, then it was 3, then it was 6. That's back to 3 again. So let's look at these methods of the troubleshoot, so they have the 3 stages here, and then on this slide we got the 7-stage troubleshooting process. So let's look at this simplified three-step method. Stage 1 is a problem will be reported to us. We're the people in charge of fixing problems. And so we're going to try to gather some information about what is going on here. We'll talk to users. We'll look at log files and devices. We'll do show commands on routers and switches to try to gather some information on what's going on. And then using our awesome collection of years of experience, we're going to isolate the problem down to one thing we think created the problem. Stage 2, I think it's that. Bad subnet mask on the interface port, for example. Then stage 3 is implement the corrective action. Change the subnet mask to what you think it should be. And then we go to this decision square thing, and did this fix the problem? If the answer is yes, we're going to document everything that we did and close the incident. And then the next time the problem occurs, we have some documentation, and we'll have to go through the whole research project again. Okay, let's say this did not fix the problem. What you immediately do then is undo what you just did and go back to stage 1 and start more research, more gathering of symptoms. You definitely do not leave that change in effect and then go back. You will find yourself changing 10 things, and the problem is not only didn't go away, it got worse, and now you're in a big mess. So if the one thing didn't fix it, change it back right away and look for another. It must be some other thing. So they've blown up this 3-step into a 7-step thing. Okay, define the problem. Okay, we got to agree upon what the problem is. Verify that there is a problem. Some people report things that they're not problems. They're training issues. Oh, I can't log into my desktop employee PC. Oh, you have your caps lock key on. You're typing the wrong password. Passwords are case sensitive. So step 2 was gather some information. We can do this from devices. We can talk to the people. Have to be careful when you're dealing with your not technically sophisticated end users, because they might not be able to technically accurately describe what's going on, or they might have hidden agendas, or they might feel guilty because they think they created the problem when they installed the Dilbert screensaver on their machine or something, which they weren't supposed to do. So sometimes users won't be straightforward with you. Once I've gathered all that information, I'm going to analyze this and try to figure out what the possible problem would be. We're going to talk about going through the layers a little bit later. Eliminate possible causes that could be what is it called? Occam's razor, that says that when all of the things that were impossible to cause this problem have been eliminated, the only one thing that remaining must be the cause of the problem. Then we're going to propose a hypothesis. This is like the dinosaur trained kid, okay, who says, I have a hypothesis. I have a theory. The theory which is mine, like the Monty Python dinosaur theory. You're going to propose a hypothesis or theory up to what you think might have caused the problem. Then you're going to test the problem by putting a change in and have a way, of course, to roll back if it doesn't work. Commit and roll back are financial terms. When you transfer your money from savings to checking, and if there's a crash in the middle of this procedure, these banks don't have marble lobbies for, there's a good reason they have these marble lobbies. They never lose money. So the banks don't want their software to add $100 to your savings account and then the code crashes before it took $100 out of your checking account. That doesn't happen. They have a procedure that says all transactions will succeed as a whole and be committed, or if there's any problem, they will be rolled back as if they never happened in the first place. It's called commit and rollback. So you need to do the same thing. If you're going to change a subnet mask and it doesn't fix the problem, you're going to roll it back as if you've never done it in the first place, because they didn't fix the problem. It must be some other thing that you haven't found yet. Then finally, when you solve the problem, you're going to document it in your problem solution database, in your incident database, and this will help you or other people to solve the problem when it recurs again in the future. Okay, so asking users. Ask the questions about, well, what's not working here? What is the problem? A user calls and says, I can't log into my workstation. And you might ask, well, can you log into the next PC at the next cube? Can you log into that workstation? Oh yeah, I can log into that, which is fine. Or they might say, not only I can't log into this workstation, I asked my partner to come over and log into this workstation. He couldn't log into it either. So chances of two people having bad passwords, it's probably actual problem with that PC. If the user can go and log into another machine just fine, it's probably a problem with his original PC. If he can't log into 2 or 3 different workstations in the cubes where he's working at, he's got some problem with his password. He's forgotten his password, or he's holding the caps lock key down or something. So we're trying to nail this problem down and try to narrow this down to, what's going on here? What are you trying to do? So what is the scope of this problem? Is it just you, or is it other people as well? You can't log into anybody's workstations in the whole room. It sounds like it's just you. Nobody else can log into your PC. Well, it's you and others. What devices is happening on? Determine when the problem occurred. When does it occur? When has it occurred? Is there a time of day issue in here? Is it? I've seen issues where people have their little space heaters on underneath their desk, and when they turn the space heater on, it created enough electrical interference that it messed up the Ethernet connection. So the problem only occurred when it was cool. Hard to do problems like that. Intermittent problems, constant or intermittent. Is it a solid failure? I would rather have a solid failure because I can count on the cause of the problem being there all the time and I can track it down. If a problem is intermittent, this can be very difficult. Users may have a rug under their desk and it sits on top of an Ethernet cable, and when they put their feet on the floor in a certain way, it's chafed that cable and created a problem. It's an intermittent problem. It's hard to isolate. Has anything changed since the last time? So let's see, in the 90s when I was working for Hardcore Technical Support Center, we would supported 4,000 different software products. And people would call in and say, oh, your print driver for your test bank, I'm trying to print a test and it won't print anymore. And you're going to say something like, well, what has happened since the last time you used it? Did you by any chance install another test bank from a publishing competitor of ours? And maybe their device driver overwrote our device driver or messed up one of our DLLs. And this is a thing where users are very, the user might not want to admit to you that he's installed some other product, or that he recently has installed a new antivirus product, and maybe that's messing up your product. So we have to use questions like these to try to determine, what's going on, what's the possible problem here. Okay, so let's assume it's not a antivirus program on the computer or a device driver program, but it's actually something on the network itself. So what are some basic things we can do to test basic network connectivity? Well, there's always our friend ping. Ping uses the Internet Control Message Protocol, or ICMP, echo request and echo reply function to send in a ping request to another device, and then if the device is alive on the network and the network connectivity is good, you'll get an answer back from it. Traceroute is a way of ping on steroids is what I call it. Ping only tells you whether the entire path worked or not. If there's 10 routers between you, you have no idea which one was the problem. So using traceroute, it sort of does a sort of a miniature ping, actually using the time to live mechanism in the packet, and discovers all 10 routers between the one device and the second device. And then if there's a failure between device 6 and 7, we can narrow that down. And that gives us a lot of useful information instead of having to look at 10 routers. Just look at the 2 where the failure has occurred. Telnet is a way of connecting to another device. So, for example, if I use Cisco Discovery Protocol and I saw that my neighbor switch had this IP address, I could tell that to it. Hopefully all the passwords are consistent. Secure shell. Within a company's protected inside, you can probably get away with Telnet. If you're going to a remote site, you probably should use secure shell because you never know who's got Wireshark and is snooping on all your traffic. So the secure shell SSH-L command, you'll be prompted to put in your user ID and password. And you'll be able to connect to a router or switch that's been configured with secure shell. And we saw these other commands previously: show IP interface brief, show IP route, show IP6 route, to check to see what's going on with the routers. Oh, here we have show protocols. Look, now he's going to call. And the reason I like show prot is that it shows the subnet mask. It shows the slash number. Show IP interface brief does not show that slash number. And finally, there's some debug commands for debug is dangerous. It uses a lot of CPU processes. Good practice with debug is only turn it on for a short amount of time, specifically as possible, to check something is a NAT translation taking place, for example, and then turn it off again when you're done. If you want to crash a router, a production router in your company, first of all, make sure your resume is up to date, and then type debug all, and it's going to be real hard to turn it off because it's going to put so much stuff on the screen that's going to be hard to type no debug all or undebug all. Okay, hang on just 1 second. I got to do something here with attendance. Let me see. Caller 6340. I don't know who you are. Are you leaving the session? Okay, maybe you're someone that's already connected under your name. If you connect with caller number through the dial-up line, I can't see who you are. I won't be able to give you attendance. So send me a chat message if your caller number is something, and I'll put you on attendance. Now let's look at the feared, dreaded, and hated OSI 7-layer model. And let's just refresh our memory here as to what devices live with what layers. So the old hubs, the old Ethernet hubs, no one uses those anymore. We leave a couple of them lying around for doing things like security snooping, or Microsoft says when you set up a Microsoft domain controller, you ought to plug it into a hub just to keep the labs going to the Ethernet port on that server and get it set up before you join it to the network, because you don't want it getting bad information from your real network. Most hubs have been replaced with standard Ethernet switches these days. So since hubs are only know about physical layer 1 things, all they know about is what kind of electricity is it, 1 or 0, what rate of speed are the bits, and what shape is our RJ45 plug, so we can plug in the electrical copper circuit and get the thing to transmit the electricity that represents the 1s and 0s. They don't know physical layer devices have no concept of MAC addresses or IP addresses or packets or frames or anything of that nature. They're just like a telephone will just, it doesn't care what language you speak in, he'll turn your voice into electricity. At the data link layer, we have things like switches. So switches are fairly smart devices. They understand Ethernet frames. They understand the concept of access to media, and you're supposed to wait when someone else is sending their Ethernet frame. Wait until they're done, and then you send it. They have a table in them, the TCAM table, the content addressable memory table, the MAC address table, so they can memorize what port you're plugged into and give you a private virtual circuit between the two endpoints that are talking once he's learned about their MAC addresses. Routers, he says that he has the router here at network layer 3 and 4, and a multi-layer switch is like a switch that has an extra card slot in it that we put the equivalent of a printed circuit board for a router into it. So routers are clearly layer 3 network layer devices because they make their forwarding decision based upon layer 3 destination networks. Switches are data link layer devices because they make their forwarding decision based upon MAC addresses. But the reason they have this shown as transport layer as well is, well, you could have an access control list on that router or that multi-layer switch. An access control list, if it's a standard access control list, it's only on the source IP address. But if it's an extended access control list, it could be on source address, destination, layer 3 IP address. It also could be on port numbers, like what your home router does when you do a network address translation. He memorizes the port numbers to make sure that the right traffic comes back. End-user systems like servers and PCs, they're said to exist at all 7 layers because they're running an application layer protocol like a web browser might do hypertext transfer protocol and create some data, and it has to be encapsulated through the whole link. Okay, now, depending on how experienced you are, here are some troubleshooting approaches. If bottom up means start at the physical layer and work your way up. So if I'm starting at the physical layer, I'm looking for things like, is it the wiring? Is it the tarnished connection on the RJ45 connector? Is the connector come loose from a device it's supposed to be plugged into? So we're looking for physical layer things first. If you have some experience and you may suspect that's a physical layer problem due to recent knowledge of this type of problem you're seeing, like the link light is not on, well, there must be a problem with the wire between the two devices. You can start at the physical layer. If top-down is if you think maybe the problem is software related, because the bottom layers are physical and the top layers are software related, the bottom layers are hardware physical related. So it's been shown in the industry that about 75% of problems that show up, there's no physical problem whatsoever. The wiring and the equipment is fine. It's bad software or misconfiguration of the software. So if you think that's the case, you can start at the top down and go application layer down. Once you have achieved some experience in the business, you're going to get to the point where your instincts now, when you see a problem, you're going to say, wait a minute, I saw that problem before, and it was bad subnet mask. This is divide and conquer. You're not starting at the physical layer and going up. You're not starting at the application layer and going down. You've got a good hunch here that I think this is a problem with the IP configuration of the device. So you start at the network layer, you go into the network control panel for a device, and you try changing the subnet mask. That doesn't look right to me, and see if that cures the problem. Of course, if it doesn't fix the problem, you change it back. Follow the path method. Look at the traffic path from source to destination. An example of this would be using the trace or route command to try to figure out where the problem is between 10 or 20 routers that are typically between a client machine and a host web server. Substitution. Physically swap. Say you think it's a bad printed circuit board in the device. You swap like the printed circuit boards, the PCI cards that plug into desktop PCs. So just take out the one you think is bad and plug in another one. Does that fix the problem? You got a known good working one? A lot of people, field service engineers, will use this technique because they're so busy. Time is money for those guys. They'll go out into the field and they'll just swap circuit boards until it starts working again. So in the field service depot repair business, which I used to work in, 75% of the boards that were shipped back from the field service engineers were not bad. They just kept swapping cards until the problem went away, and they weren't going to swap those other cards back. That would take too long. These guys were all on maintenance. They paid the same thing exactly. And so us field service depot repair technicians would get to sort through and determine which boards were good boards and could go back into the inventory, and which boards actually needed to be repaired by resoldering something. With a comparison, we're going to try to compare the problem with a problem device with the working one and try to figure out what's going on. And then we have our educated guess, or sometimes called in the industry a WAG. That stands for wild ass guess. Based upon your troubleshooting experience, you might be able to make an educated guess based upon your hunch or your intuition of what's going on here. Okay, guidelines for selecting a troubleshooting model. So if it's a software-oriented problem, application layer down, because that's all software, from the application layer going down until the software meets the hardware. If it's a brand new problem, try the bottom-up method. If you don't have a lot of experience, try the bottom-up method. If you have a lot of experience and have seen these similar problems before, you might go ahead and go into the divide and conquer method. Like my hunch tells me this is a bad subnet mask or the wrong port number on an access control list. I might try to correct this. If it's hardware-oriented or cable-oriented, or if it's a complex problem, you don't know whether it's hardware or software yet, start at the physical layer and work your way up. So some things we can use for software troubleshooting tools. Network management tools of devices that can monitor at the device level, like simple network management protocol, or the Hewlett-Packard type of programs that are costly and do this, but they're free ones to do the same thing. We want to determine what's going on. So we can try this to correct network problems this way. Another option is the knowledge bases. Now, when I was at Harcourt in the 90s, we subscribed to a thing called Microsoft TechNet for our Microsoft devices. And we paid a yearly subscription fee. It was several $100s. And they would send us a bunch of CDs with troubleshooting information on them. It is now entirely free. You can open up a support incident with the Irving-based product support services that Microsoft has, and they'll charge you, it's about $400 per problem. It doesn't matter whether they solve it in 5 minutes or 10 weeks. They're going to work with it until they solve it. But all the information they have access to, which is this TechNet library, you have access to for free. So if you want to do your own troubleshooting, you can do it for nothing. And try to solve the problem for your employer at no more cost than the salary that you're using trying the time to solve the problem. Baselining tools, we talked about some earlier stuff. We can use simple network management protocol or show commands or system log files to try to determine what's the normal baselining network performance of our devices. What are their normal configuration parameters? Okay, good old Wireshark. This is such a wonderful tool. For many years, particularly back in the 90s, we had to rely upon very expensive, I'm talking about $25,000 boxes. The General Radio Sniffer was the one product that you would attach it to a tap on your network, and it would tell you exactly the same thing that Wireshark would tell you. It would show you stuff with the physical layer, the data link layer, the network layer, the transport layer, and so forth, and you could use this to try to analyze protocol problems or hardware problems in your network. And very expensive consultants would have these devices and would come into your company and try to help you solve problems. That's causing you to lose revenue. So these days, anybody in the world can get a copy of Wireshark for free and put it on a $300 laptop, and that's the equivalent of the $25,000 tool that we had during the 90s. So I like Wireshark because it's able to dig down to all the layers and show you the MAC address, the IP address, the source and destination address. It's got great filtering capability. You can say, I only want to, user's reporting problems with his workstation. Instead of having to look through all the millions of packets on your whole network, you can filter it by his IP address and then see what's going on, just the traffic to and from that device that's causing you the trouble. So this is very helpful for analyzing problems. Some other hardware tools, digital multimeters. What's the name of that Chinese tool store? Harbor Freight oftentimes has a coupon where you can go there and you'll get a free multimeter. Well, they're down to like $5 now. So that you can use the probes and the multimeter. You can measure. A cable, does it have continuity from one end to the other end? You can use to check for that. More sophisticated devices like cable testers, we can plug Ethernet cables into them and run an end-to-end test. In the $100 to $200 range, you can buy these testers where they have a dummy plug that goes at the far end of a circuit, say back in a wiring closet, and then you plug the cable tester into a cube or an office of an employee, and it'll test the cable end to end. Make sure that the wiring is correct, the wire map is correct, there's no cross cables. Some of them will even measure with a simple resistance test and give you an idea how long the cable is. Cable analyzers, these are $3,000 and $4,000 devices. When you have a contractor come in and wire your new lease space, and you're going to have to, because the trend now is when the last tenant leaves, all the wiring is ripped out, all the devices are removed. So you're going to have a contractor come in and wire your facility for where your cubes and offices are after you have the remodelers come in and fix your space up. And then they're going to use cable analyzers to prove that all these cables pass not just a resistance check and a wire map check, but all the 10 or 12 actual specs of, you know, the EIA, TIA 568A and B specifications for wiring. It's got to have a certain amount of crosstalk and so forth. And they can furnish you with an as-built wiring diagram for your space that you're a tenant of now. Portable network analyzers. Fluke makes some devices that are in the $10,000 range where you can, if you think there's a problem with the network drop to a particular room of a particular office, you can unplug the vice president's PC and plug your analyzer into the same port. It'll tell you what VLAN it's on. It'll tell you if it's getting a DHCP address. It'll check all the stuff that these other cheaper analyzers will do and give you more information besides. And it wouldn't be a Cisco slide if it wasn't some Cisco marketing buzz stuff on it, but Cisco makes a product called Cisco Prime Network Analysis Module that is made to plug into the modular devices like those big switches and routers that maybe a service provider or a big company would use. They have all these extra slots in them. Well, you can make one slot, you can plug in the equivalent of a network analyzer on a card, and it'll integrate right into the iOS software, and you can use this with your simple network management protocol. Okay, Syslog Server is when you notice that when an interface goes down because the wire came loose, it puts a little thing on the screen, it chops up what you were typing, and it says up, down, interface port G00, down and down now. And then this is lost off the screen. Now, if you weren't sitting there logged into the router, right now, you wouldn't see that. And the router only has a limited amount of scrollback memory that he can retrieve from this. So what you can do, we talked about this in a previous thing, was set up a Syslog server. Set up any expensive desktop PC, any old cast-off device, buy a cheap $50 huge hard drive and put it in that, and save all the log files for all your routers and switches on that one device, maybe even your servers. So you can go back to these logging files later and look for problems. Or if an intruder has broken into your system and you're using good network time protocol, so you can match the time, you can check and follow the bad guys as they go through your system. I didn't mention this in the network time protocol thing. How many network time protocol servers must you have on your network? And I say it must be 3 or more. Here's why. If you have one, is it accurate or not? You don't know. At least the log files are in sync with each other. If you have 2 and they don't disagree with each other, which one is right? I don't know. So if you have 3, well, at least if one of them is wrong, the other 2 must be the one that is still correct. So this is the old military tell me 3 times thing, redundancy. So there were these 8 different levels of logging that could be sent to our hard drive. So we could only put it at level 0. Oh, I crashed, you have to reboot. All the way down to number 7, which is warts and all, everything. So you can choose what level you want to send depending on how big your hard drive is on your logging server, and that'll give you some useful information. Okay, let's look at physical layer troubleshooting. Symptom, performance is lower than the baseline. And you did the baseline measurement, so you know something's going on. So overloaded, underpowered servers. Remember that the server guys will always blame your network for the problem. Switch or router configuration is not proper. You have too much traffic on a low capacity link. You're losing frames. This would cause lower performance that's less than the baseline. So you measure before, so you have a good idea what should be going on here. Second, loss of connectivity. Maybe a cable has become disconnected or become corroded. It's possible that the printed circuit board in the device has gone bad, but that's kind of unlikely. These printed circuit boards and electronics are kind of reliable, and they normally, it's not a hardware failure. Normally it's a misconfiguration or the cable that's plugged in has got some problem. So how can we verify this? Just do it with quick thing. Intermittent connectivity could be a loose cable, could be oxidized connection. Due to the magical property of wires, you can sometimes simply unplug a connection and plug it back in again, and that sort of wipes the little gold-plated connectors clean, and the problem goes away. You were using a cheap 49-cent cable or something like that, and it started oxidizing. Okay, the category symptom of network bottlenecks or congestion. So if you're using a routing protocol that has backup routes, or you're doing load balancing and a route fails, well, you're going to have less traffic, total traffic that you can send your packets through. So you can get some congestion. Maybe we're using Ether channel with 2 fiber optic cables to the library, and they're tearing the rotunda building down, and they cut one of those cables. So our actual bandwidth capability is dropped in half, and that could cause some congestion. High CPU utilization rates. You're trying to use a branch office router that's and it's trying to use it over what it was designed to do. So we can have some show commands we can type on the router or switch to see how busy the CPU is, and it should be way below 75 to 50%. If it's any higher than that, it's time to buy a more expensive device that has the greater power for this. Just like you should buy a more powerful server for a file and print server, not use some cast-off desktop PC. Error messages on the console could be a problem. So things, the interfaces drop up and down. I'll tell you a problem we used to run into in our Cisco lab is I used to allow the students to plug and unplug those dark blue serial cables between router 1, 2, and 3 when they do a lab. And it turns out those little minuscule, tiny connectors on that Cisco smart port, serial port, were never intended to be plugged and unplugged, dozens, hundreds of times. And so what happens is they would get bent, and then the students would try to do a lab, and they would notice their serial ports go up and go down and go up and down on a sort of a random basis. And when I got one of these jeweler's eyeglass things and looked very carefully at the cables, I noticed that the pins in that little tiny plug on the serial port had gotten bent and displaced. They're $500 a piece. But we had SmartNet, so I sent about 20 of them back to Cisco, and they sent me brand new ones. And that was the day that I hammered down and locked down all the dark blue cables between all the routers so that they don't have to be connected and disconnected anymore. Fortunately, in all the Cisco laboratories, it's always exactly the same connection. S00 router 1 goes to S00 router 2, and S001 of router R2 goes to S00 router R3. There are other solutions here at the lab, at the Cisco lab at Northeast Campus. They bought these adapters that plug into the Cisco port, and then it terminates in the RJ45 connector. So you can make up your own serial connections using the standard dollar Ethernet cables, and that won't wear down the plug itself. Okay, power related. Some devices have, if they overtemp, they get too hot, they'll shut down. Make sure the fans are clear and they're clearing everything out. Some of these fans are very, very, very noisy. That Cisco 4000 switch I have in the back of the classroom, when you turn it on, all heads turn. It's as loud as a vacuum cleaner. Okay, hardware faults. actual problem with a printed circuit board, that's kind of rare. But maybe a NIC driver file in a server is bad, and it's jabbering or causing problems on the network. And so we have to want to try to troubleshoot that problem down with using show commands, look for interface errors on any particular interface port of our router or switch. Grounding is important. In our classroom, we have very heavy-duty grounding so that there's no ground loops, and the lawyer for the district doesn't care about grounding loops, but he doesn't want you guys to get shocked because he doesn't want to get sued. So since the racks are grounded safely, you can't get shocked if there's a hardware fault in the device. Cabling faults. Wrong type of cable, the cable has been damaged, or the little pins have gotten bent. Making your own cables, well, that's fun to do just to see how it works. I wouldn't try to use your own crimped connectors in a business environment because later on that cable is going to fail. Just go to a high quality supplier and get good quality cables. A student turned me on many years ago to monoprice.com. They have very high quality cables at a very low price, and they're good and reliable, and I've been using their cables in the lab with you ham-fisted students getting your grubby grimies and messing up all those connections for over 15 years now, and none of the cables has failed yet. Okay, attenuation is a lessening or a diminution or a lowering of the volume or amplitude of the signals on a wire. And if you use a cable that's too long or it's got dirty contacts on it, that can reduce the bit level to creates a problem. It's supposed to be able to go 328 feet. But if you have the wrong type of cable or it's got a bad high resistance connection, that can lessen that. Ethernet will run over barbed wire. It can usually recover from almost anything, but you could overload it. You could overwhelm it. Okay, electromagnetic interference type of noise or radio frequency interference can cause interference in an Ethernet cable. Normally the twisting together of the wires, the 8 wires that are twisted together into 4 circuit pairs, that twisting together sort of performs a self-cancellation effect and tends to reduce any outside interference. However, if you're next to a giant welding machine at an aircraft factory, it could be overwhelming and you might need to use shielded twisted pair cable to reduce problems in that wire. Okay, what are the interfaces? What if they're not configured properly? Well, in the earlier iOS versions, when we had our serial ports between devices, we had to use a clock rate command. Incorrect clock rate command could cause a problem. We had to specify which port was providing the clock and which one was not. If the interface has been no shutdown, that will cause a problem as well. This clock rate command has been pretty much fixed in the newer iOSs from 15.0. They automatically apply a proper clock command. And anyway, when you go out into the real world, you will never have to apply clock rate commands because you always be clocked to your service provider. He will give you the master clock. Okay, exceeding the design limits using a $1,000 branch office Cisco router and attempting to use it as the core router for the whole company, that's too much. You're going to get CPU overload. That device is going to crash and drop packets. And if it gets too seriously overloaded and it blows his mind, he'll actually reboot the device, and you'll have 3 to 5 minutes of downtime. Okay, let's look at the data link layer. If there is no connectivity at the network layer or above, maybe this is a data link layer problem. Well, maybe it's a physical layer problem too, but let's say you've ruled out physical layer problems. Now you're looking up at the data link layer problem. So if a network is operating below baseline levels, how about an extended ping or continuous ping? At the workstation, you can type ping 10.1.2.3 -T and it'll send continuous pings. On the Cisco device, you can do an extended ping, and instead of using the little tiny micro-sized, very brief ping packets, you can put giant ping packets in there to really stress the connection. This is a technique that engineers would use if they brought up a lease line, like a T1 line, between 2 office locations. They would flood that lease line at full bandwidth to try to determine if he has any, what they call impairments, any problems with that line, to try to make sure they're getting what they're paying for. We don't want too many broadcasts. The major source of broadcast in modern networks are ARP requests and DHCP requests. If if you have too many devices in one broadcast domain and they're all ARPing to find each other's MAC addresses, or using the neighbor detection thing for IP version 6, which is multicasting, which is almost as bad. We just don't call it broadcast in IP version 6 so you can feel better with it. You need to divide your network into smaller broadcast domains. As a general rough rule of thumb, the /24 subnet mask 255.255.255.0 is a good size, maximum size network to use in a huge company. So it corresponds to a floor of a building or a department or division of a company. You don't want to use much larger networks than that because it's going to be too many cumulative broadcast and multicast packets being sent around that network. Console messages are sent by routers and switches when they see a problem. If a keep alive is expected from a RIP router and it didn't get it, you're going to see some routes being dropped from the routing table. So the most common type of message would be you're getting a layer 2 problem. Maybe it just goes down, maybe it goes down and up and down and up and down and up, like the serial ports after my students had hammered all those local pins. I'd say, oh, well, don't use that router today, use another router, and I'll try to get that fixed. And eventually they hammered about 20 ports that way. Okay, at the data link layer, by default, all Cisco routers use the Cisco HDLC encapsulation type on serial ports. However, if you're talking with a brand of router that's not Cisco, they don't. HDLC is not consistent among vendors, but point-to-point protocol is. You could switch to that. Point-to-point protocol is a protocol that all dial-up. Remember the old dial-up routers, the screeching cat's noises? Think of being an America Online support tech guy, and you're trying to figure out which one of 10,000 different modems are you using, and I have to troubleshoot and know about 10,000 modems. Well, every single dial-up modem in the world uses point-to-point protocol for the dial-up connection. Even the telephone company, old DSL, uses a variation of point-to-point protocol called point-to-point protocol over Ethernet. So if the encapsulation types don't match, they can't communicate with each other. Address mapping errors. We need to be able to use ARP and map our layer 2 data link layer address with our layer 3 IP address. So that's the reason that your first ping normally fails, is in the background. ARP is sending out the broadcast saying, you ping that address? I have no idea what this data link layer MAC address is. I need to ask him for it. And that causes you 1 or 2 dots, and then it works fine for 3 or 4 minutes. Framing errors, noisy serial ports, bad cables, a faulty network interface adapter, more likely in a user device than your routers and switches. They're pretty good. Duplex mismatch. One side is half duplex on a switch, one side is full duplex on a switch. That can cause a lot of late collision type errors. This problem has been pretty well solved. 15 years ago, we saw this a lot. The auto configuration MDIX transistors that are in modern devices are usually really, really good about not having any duplex mismatches anymore. But you might have to go into 2 switches that are linked together and make sure they match manually, duplex full or duplex half on both sides to make sure that doesn't work. Okay, spanning tree protocol. Loops. Well, we're supposed to have triangle-shaped loops between our switches, or in the leaf and spine thing, every leaf goes to a spine, every other spine, every spine goes every leaf. So that's a lot of loops in there. Well, spanning tree protocol is going to make sure that the ports don't create a loop where a broadcast storm can occur. But our users will oftentimes change the topology by doing something like buying a cheap 5-port switch from an office supply store and plugging it into a cube or a conference room to add devices, and those things don't have spanning tree protocol. That changes the topology of our network. If they have the wrong type of MAC address, they can actually try to take over STP. So there's some commands we can do in Cisco to prevent this. We could do BPD, Bridge Protocol Data Unit Guard, and if it detects any other foreign devices plugged in there, it'll kind of partition them off for 300 seconds or 299 seconds. Okay, network failure. Network is completely non-functional. That's going to affect everybody. You're going to know about this right away because the help desk phones are going to start ringing off the wall. If you're running simple network management protocol, you'll know this right away. You move when the phones start ringing. Okay, now we have just one department that's gone bad. Maybe just their one switch has got a problem. So this could take some time to solve. Okay, general network issues. Maybe someone in one part of a large company had a slight change in the topology over in the new engineering lab, and it somehow affects the areas on the rest of the network. But there's a new VLAN here. We didn't map it into the allowed VLAN statement. It has a different native VLAN, and all the devices are being consumed with native VLAN CDP mismatch messages. So in a large company, when there's not just one or two guys in one department, they all know everything that's going on, we need to cooperate with the other departments and other divisions, see who has been making changes. For connectivity issues, check for any connectivity problems, such as power, layer 1 problems. Maybe it's an internet service provider problem. I hope it's the internet service provider problem, because I won't have to fix it. They won't let me log into their devices. Look in the routing table. Are there new routes that shouldn't be there? Are there missing routes that should be there? Neighbor adjacencies. They were talking about, he's not talking about show CDP neighbor. He's talking about if you're running OSPF or EIGRP, they form neighborship relationships with the other with hello packets. Make sure those are proper. Like if you're running OSPF, show IP OSPF neighbor, and make sure R2 can see R1 and R3 connected to it. The topology database on OSPF should have certain entries in it that he's learned from this flooding of data back and forth. Okay, access control list. Oh, these are double-edged swords. They're you got to be careful with them. If it's an extended, complicated list, you want to make sure the entries in the right order, and you've placed the list in the proper place so that it doesn't inadvertently kill other traffic. So it's got to be applied to the correct router device in the correct direction. ACLs are per direction, per port, per interface. The orders of the entries should be in the correct order. You can't have a permit any and then deny the boss's worthless nephew. Otherwise, the first entry is permit everything and he never gets filtered. All access control lists have the implicit deny any at the end for access lists for IP version 4. IP version 6 access control lists, in addition to the implicit deny any at the end, have a couple of implicit permits to allow this neighbor detection, the equivalent of ARP, to take place. Otherwise, we'd break our IPv6 network if we put any kind of IPv6 access control list on it. IPv4, we have our wildcard masks, which are the mirror image of the subnet mask. That can easy to make a configuration error there, and you deny traffic more than you intended or less than you intended. IP version 6 is a little bit easier in this case. Transport layer protocol, excuse me. We have to be careful about the correct ports that they be specified. A gotcha, for example, is FTP, file transfer protocol. He needs 2 ports. He needs ports 20 and 21. So if you open up a firewall for 20 but not 21, they can log in, but they can't transfer files. Source and destination ports have to be the correct inbound, outbound ports. Placement. The established keyword for TCP is intended to, when someone establishes a TCP connection within the company to an external web browser, to a web server, when the answer comes back in, the port numbers and everything's going to match. This is what all home routers do by default. Misconfigured access control lists can also cause problems for protocols other than TCP or UDP for uncommon protocols, but that's kind of out of the scope of CCNA. Okay, network address translation for IP version 4. We don't need network address translation for IP version 6 because we have more addresses than we ever need. But IP version 4 we're running out, so we had to do the NAT. So you have one address from the cable company, and you can have two dozen devices at home. So when a workstation sends out the DHCP request packet, that's the source IP address is 0000. NAT requires valid destination and source IP addresses. So DHCP can have problems running over a router. Okay, so the problem is if it's a broadcast, if the data link layer broadcasts don't survive router trips, use the IP helper address feature on a Cisco router. so that he converts that broadcast into a unicast message that can go through the router to the connection where the DHCP server is located. In our case, it's back at the Trinity River downtown campus. DNS server doesn't know what IP addresses are inside the protected inside network. So IP version 4 helper can help solve this problem. Simple network management protocol is sort of a UDP type of thing. So that can be a difficulty connecting to those routers. Now remember, at the CCNA level, we're only responsible for configuring IP helper for DHCP. It does 6 other things, but you don't have to know how to configure those. Tunneling and encryption protocols, that might prove a problem with NAT. However, NAT is absolutely great. For standard web browsing and email stuff, NAT is just great. It's very low latency, 1,000th of a second processing time. And it really helps solve the problem with running out of IP addresses that we started in the middle 90s. Okay, at the application layer, we have some different application layer protocols we're supposed to know something about for CCNA testing purposes. Secure Shell and Telnet, ports 22, 23. Hypertext Transfer Protocol, port 80 or port 443 for Hypertext Transfer Protocol Secure. FTP, ports 20 and 21 for transferring files, but you have to log in. You can change directories, kind of like in Unix. Trivial File Transfer Protocol is stripped down version of FTP, no name and password required. You're stuck with one directory. Excellent for backing up and restoring configuration files and IOS routers and switches. Your cable company uses this to configure your cable modem. If you increase your bandwidth, they'll send a new configuration file to it. If a new firmware comes out for it, they'll TFTP it to your device and upgrade it. AT&T uses this to upgrade my AT&T home router device, which is a combination home router and Wi-Fi access point and 4-port switch home router type thing built into the box. A simple mail transfer protocol, not to be confused with this dyslexic neighbor, simple network management protocol, because they both start and end with S&P. Simple mail transfer protocol is what transmits mail when you click send. POP is what picks up mail. So most people don't use these protocols at home. They use a web-based email client like Microsoft Hotmail or Google Mail or Yahoo Mail or something like that, and it's all done as hypertext transfer protocol transactions. The DNS is the directory information of the internet that when you type in an address to create that packet, I can't put Microsoft.com as a destination address. It's got to be the actual IP address. So DNS will look up that for it, and it'll punch it into that packet when it creates it. We haven't talked that much about network file system. Network file system is the equivalent on Unix and Linux machines of server message blocks, SMB, on Microsoft machines. It allows file and print sharing to take place. So when you come into the lab and log onto a TCC college computer, server message blocks is what gives you access to the shared files and the printers. If you're using a Linux machine or a Unix system, NFS is the same exact thing. It's considered an application layer protocol. Although some people would argue it's a session layer protocol. Okay, now let's look at IP connectivity. Bottom-up steps to the physical layer. So check physical connectivity at the point where network communication stops. How did I determine where network communication stops? I ran traceroute, and it told me there was a break between router 1 and router 2. Restore that if needed. Check for duplex mismatches. Well, we'll run show interfaces on both the router ports that connect to each other for the two routers. Make sure that the duplexes are correct. If they're not, there probably would be these days, but if they're older devices, they could be wrong, and you could manually set up both to full or half duplex. Check the data link and network layer addressing between these two devices. Whether the subnet mask consistent or the IP address is proper. Verify that the default gateway is correct on a endpoint like a switch or an employee PC. If the default gateway is not correct, they could do local traffic to another server in the same department, but they wouldn't be able to leave the department. 5, ensure the devices are determining the correct path from the source to the destination. Well, let's check on our routing table for our routing action. Let's check on our MAC address table for the switch to make sure they know about how to get it to the other device. Number 6, verify that transport layer is functioning properly. Oh, do you have any access control lists that are inadvertently blocking traffic that you did not want to block? And finally, number 8, DNS. It's always DNS. Go to the Reddit forums. It's always a DNS issue a very large percentage of the time. Make sure DNS is proper, because users are not going to type in 128-bit IPv6 address. They're going to type in a friendly English name. And if there's a DNS monkey business, shenanigans are going on, that's going to mess up the action. Okay, end-to-end connectivity problem, initiating troubleshooting. So we discovered there's a problem. We try to ping from PC 1 to server 1, and ping doesn't work. So the next step is let's use traceroute and see if traceroute can tell us where the failure has occurred, because traceroute's going to go to R1 and then to R2 and then to R3, and if there's a problem between any of those 3 routers, that'll tell us where the problem is stopped, where the connection is stopped. So start with the physical layer, show interfaces, and this shows us, of course, it shows us the IP address, what's up and up. Okay, look at those orange entries, the 0 input errors, the 0 output errors. There was 1 interface reset, that's okay. There's 11 unknown protocol codes. I'm not concerned about that. If it was showing 10 or 20,000 or millions and millions of entries there, that would be a problem. So we're looking at interface status, drops from the input-output queue, and input and output errors. So we don't have any here. So we're in pretty good shape. Probably not that port. Check for duplex mismatches. So we're a little lucky here. On switch 1 and switch 2, switch 1 is full duplex, and switch 2 is half duplex. That's going to be a problem, because full duplex devices think they can transmit and receive whenever they want to at any instant, whereas a half duplex device, like an old hub, will not transmit if he hears any other traffic. Well, S1 thinks he can transmit whenever he wants to. He just keeps transmitting. Switch 2 tries to send something, and S2 interrupts him, and he generates that as an error, like a collision error. So these need to be fixed by reconfiguring them to be both the same, either both half or both full duplex. Let's check addressing then on a local network. Let's verify this relationship between my layer 2 MAC address and my layer 3 IP address of all my devices. So on a Windows workstation, you type ARP-A, and this will show it to you. On a router switch, you type show ARP, and you can see that all these relationships are consistent and proper. VLAN assignment. If we have a VLAN on the wrong device is plugged in and it hasn't been configured to be on VLAN 10, in this example, the first orange entry on S1, it's assigned to VLAN 1, it should be on VLAN 10. Because VLAN 1, we're leaving that alone, we're going to move the users to VLAN 10 and VLAN 20. So we can go to that switch port, switch 1, port 01, and say assign it to VLAN 20 and cure that so that it's in the proper location. And its IP address matches all the other devices on that VLAN. Okay, default gateways for R1 is using 192.168.1.2, and PC1 is 10.1.10.1. That's not configured properly, and it should be the same network prefix. So on a PC, we could show route print and see what it's set to, or IP config, or go to the network control panel if it's statically assigned, but you're probably going to be DHCP. On the router, we can show IP route to make sure they have paths and have connectivity back and forth. IPv6 default gateway. How do we configure that? Well, it could be configured manually, or by default, he's going to try to use Slack, because by default on Windows PCs, when IP version 6 is turned on, the box that says obtain the IP address automatically is checked. He's going to use Slack, which is where I send out this router request to the router to tell me what his IP address is and what network I should use. And then I'll just make up, out of whole cloth, I'm going to make up a host address, a 64-bit host address. If we've actually configured a DHCP version 6 server on the network, probably going to be an Intel box, could be a router. then he'll give us all the stuff we need, DNS addresses and so forth. So this is the idea with IP version 6, that it would auto-configure itself automatically, and nobody would have to configure anything. So let's make sure that the routing table is proper in the device. We're going to look through how does a router figure out which route is the best route in the routing table. Doesn't matter whether it's IPv4 or 6. He wants the longest bit match, the longest prefix match. If there are more than one entry that matches, sort of matches, the destination address of that packet that he's trying to determine where to forward it to, he's going to choose the one that has the most bits that match. So in IP version 4, for example, if I have a 28 and a 24/2824, the 28 is the better match because he matches 28 bits instead of 24 bits. He'll choose that entry in the routing table, wherever its X interface he's supposed to go to. Transport layer. Here's a little trick here. I don't think I've talked about this before. You can use Telnet as a web browser. Well, kind of. So for example, web browsers are port 80 for regular unencrypted web traffic. You can type the command telnet, and these typed in IP version 6 address. And normally you would telnet, and then you wouldn't put anything after that. The default port for telnet would be 23. It would assume that. You could type 80, and it'll try to open up requests to the web browser. Now, you're not going to get the web browser page, but you're going to see the code that comes back from the web browser saying this is not the proper type of request. I had a guy show me one time, and I forget how he did it, how to log into port 25, which is Simple Mail Transfer Protocol, and he sent a fake message to whitehouse.gov and show me how I could do that and be totally untraceable by simply using Telnet to go into a Simple Mail Transfer Protocol server, or a company, or an internet service provider. So no, I don't remember to do that. Don't ask me how to do that. I don't want to get in trouble with the FBI coming. But that's another troubleshooting testing method. On routers, we can verify our access control lists. In this case, access control list 100 has been put into the wrong, inbound on the wrong port. It should have been set on the 0 port, not on the gigabit port. So we can remove it. We don't have to redefine the access control list. It was okay. It was just improperly applied to the wrong port. Simply say no IP access group 100N on the gigabit port where it should not have been, and reapply it to IP access group 100N on the 0 port. In this case, it was determined that fixed the problem. And the last thing we got here is verify the DNS. It's always DNS. So how can I make sure that the DNS is working properly? Well, look at this. We haven't seen this command before. On the router, he's using the command IP host IPv4-server 172.16.1.100. And then when he types ping IPv4-server, the DNS type function looks it up and it works. That's kind of like a little built-in DNS server on that router. If you have an external DNS server working in your enterprise, I could say ping server 1. If DNS is working properly, he'll look up that address, resolve server 1 to the actual IP address, and ping it properly. And you can check that way to see if it's working. On Windows workstations, there's a program called NSLookup that you can use to test and troubleshoot the DNS server in your enterprise to make sure it's working properly. Okay, hang loose 1 second here. I'll go back to this greeting page because I want to reshare one thing with you guys. Okay, so today we covered the Module 12 troubleshooting. Thursday we're going to cover 13 and 14 on virtualization automation. Please, guys, complete the student satisfaction survey. The easiest way is to go to my TCC Blackboard. And go and click this class, and then just, okay, I'll go back to the top here. Go to this class, and you'll see the thing that says course evaluation. Click on that link, and that'll take you right to the WebAdvisor self-service page where you can complete the student satisfaction survey. Totally anonymous. I won't be able to see anything you do. This is your chance, your one chance to comment on my choice of bath soap, because I won't be able to see who said what. And I won't be able to see anything at all until the final exam grades have all been turned in. So this is optional. No one will, you won't get in trouble if you won't do this, but we'd like to complete some stuff from our students. Cisco, of course, makes you take their course feedback form before you're allowed to take the final exam in this course. So if you want to take the final exam, take the course feedback form first. And I'll turn that on real soon now so it's available, because we're in the last couple of weeks here of the semester. And you can get that out of the way. It only takes 5 minutes. Okay, guys, I think I've covered everything I need to cover for today. So I'm going to go ahead and stop recording. Give me my mouse.